Okay, we'll take a look at the next couple pages. We're starting on circles and facts surrounding circles, like angles and arcs and chords. So here we go. So for my problem 39, which I think might be your problem 41, it says that AE is X and EB right here is 6. DE is 7 and EC is 4. As I've been harping on all year, I have a lot of you not wanting to take the time to write those numbers on the diagram, and that frequently leads to just unforced errors, just very simple things that you know better than. So anyway, our rule here is that if you ever have two chords that intersect inside the circle, it breaks them into parts such that the product of the parts is the same value. 6 times x equals 7 times 4, so 6x equals 28. So x is 28 over 6, which of course reduces to 14/3. And I know sometimes you guys feel uncomfortable when you don't get whole number values, but this problem was designed to do so. For letter B, same idea. 7x DE is 9 and EC is 14. So 7 times x equals 9 times 14. Now, this is one of those cases where I like to look for, little number sense things. So when you divide both sides by 7, instead of multiplying those together, what I notice is that 7 goes into 14 twice, and so I get 18. Now, if you had multiplied and then did division, it's not a problem. You'd get the same number. I just thought that was easier to see that that became a 2. So 9 times 2, 18. Now, sometimes the values intersect inside the circle, but sometimes they intersect outside the circle. And so this has a slightly different pattern, which sometimes turns into a quadratic. So MN is 5, NO is 12. Let's see, MP is 6, and this one is X. So according to our rule, it says the whole thing, which would be 17, 5 plus 12, times the outside piece, is the same thing as 6 plus X times the outside piece, which is 6. Well, I would go ahead and call that 17 times 5, and this would be 36 plus 6x. So let's see, 17 times 5 is 85. So that's looking pretty good. We just have to move some things around. So we'll subtract 36 from both sides. And so 85 minus 36, we're looking at a simple number of 49. So 49 equals 6x. And so I got that x is 49 over 6. And I don't think there's much more that I could do with that. Then over here is the one that I really wanted to get to, which I mentioned a second ago is quadratic. It's sometimes when the x value hits on the outside, that's going to make it a little bit more challenging. So let's see what happens. So again, we take the entire value, which is 12, times that outside piece, which is 5, is equal to the entire thing, x plus 4, times that outside piece, which is x. Now, not everybody, uses that terminology a lot, but whenever you end up with a problem that ends up with an x squared being equal to something, that's called a quadratic. Now, this is not like we did a couple of pages ago where it was where the question was to simplify or to factor. This is to solve. I want to find the value of x that makes this true. So if we ever do that, we're going to go and subtract 60 from both sides, which is going to make this negative 60. I'm going to do a little factoring. And if you remember, when we factor, we want to take the product of A and C, which is negative 60. That number is here. And of course, a fairly obvious set of multipliers is 10 times 6 would be 60, and I could add them to be 4 if we had a negative here. So my factoring does not require the full box and everything. I can just jump right here because A is 1. Remember, an A is 1, we don't have to do the whole thing. But I'm still not done because the problem didn't ask me to factor. It asked me to solve. I have one step further to go. and that is this value will be 0. The only way a product can be 0 is if you multiply and one of the values is 0. So either x is negative 10 to make this part 0, or x equals positive 6 to make that part 0. But it doesn't make sense in context of our picture to make x negative 10 since x is a distance. So that means x equals 6 is the only value that is legitimately true. But like I said, let's go ahead and check this. So if x is 6, we already said this was 60, and if x is 6, that would be 10 times 6. And what do you know? 10 times 6 is, again, 60. So we did okay. All right, moving on to angles instead of segment lengths. This says that the angle ABC is x, but its arc is 78. And so that means the measure of the angle, the relationship is that the angle is always half the arc, so x should be 39 degrees. Easy peasy. Conversely, if ABC is 27, then the arc out here is going to be twice as big, because if I had to cut it in half to get to the angle, then I'd have to double it to get to the arc. 54 degrees. Easy. All right, moving on. Okay, problem 42. Okay, now again, new one. Instead of, again, when the things intersect on the outside, it usually creates slightly more complicated stories, but always, always, always mark your picture. So it says arc OQ is 68, arc NP is 24, the angle is X, and our story was you're supposed to find the average difference, which means take the two values, divide them, subtract them and divide them by 2 would be that angle. And some people do this in different ways. You could divide both of them independently by 2, kind of a distributed property, or we can just go ahead and say that's 68 minus 24 is 44, right? And then if we're going to divide that by 2, I got 22, so x is 22 degrees. This one is a little bit harder because just the order of it, and I know that that makes it more difficult for a lot of people to follow. This feels strange in terms of how it lays out, but again, same process. Outside minus inside divided by 2 should be that angle. Not really a fan of having that divide by 2 there, so I'm going to multiply both sides by 2. And of course, 74 times 2 is 148. And then all we need to do is add that 48 to both sides, and then x would be 196, which is a little interesting. I guess this one should have been a major arc and therefore should have had 3 letters. But moving on. FDG, what is FDG? Well, see, F to D to G. Now notice the third letter that is indicating that this is a major arc. So one thing you want to remember is that semicircles are always 180 degrees. So what I notice is this portion of the circle right here is 180, and then I just had to add 38 more to that. 180 plus 38, that measure of that arc is 218 degrees. Measure of arc FDG, 218. Now FG is what we're looking for this time, and that's interesting because what this is just exactly, see, this is a semicircle right here, so this time I take the 180, but I need to lose 38 degrees to get down to the value, so that would make it 142 degrees. Perfect. All right, 2 more to go, and then we're done with this set of pages. So now it's asking me, what is the measure of our DTC? So D to T to C. So that'd be this arc right here. This is what I want to know. But it says arc CSD. This guy, CSD, that's this guy right here. And this guy right here. Well, see, because both of those arcs, both of those angles intercept arc DC. See, this angle T opens up on DC, as does S. That means those two angles have to be the same as each other. So that's 5x minus 17. The measure of the first and the second are the same. So we're going to move things around. I'm going to subtract 2x from both sides, add 17 to both sides, and I end up with 10. And that's a good answer, but again, it's not complete because it didn't ask for x this time. It asked for the measure of the angle. So angle DTC is going to plug in x right here. So DTC would be 2x plus 13, where x is 10. So 20 and 13, so that'd be 33 degrees. And our final one, this should be a nice easy one. It's actually a problem we've seen before, quite literally, is that anytime you have an angle, a quadrilateral that is specifically inscribed inside a circle, then the opposite angles have to be supplementary, which means if B is 103, then X has to be 73. And if 86 is A, then angle C, Y is going to have to be 94 degrees. Now, the reason for that is a little bit interesting. And I will just remind you very quickly. But let's just say you're looking at these two angles right here. Let's take a look at angle X. And keep in mind, angle X then opens out onto this arc. So X is half of the pink arc. And 103 is right here, angle B. Angle B opens out onto this entire arc. So if you notice what happens, these two angles open up in such a way that they should be half of what they intercept, but they intercept together the entire 360 degrees. And so if the angle is half of the arc, half of 360 would be 180 degrees. And that means they have to be taking care of the whole circle. All right. I will see you back in class. Bye-bye.